Greetings, Earthlings. Today I want to look at the video output from the Nova 445 graphics adapter. And what you can see on the screen here, so this outputs a monochrome composite video signal. This is what a composite video signal looks like. You have 0 volts is sync, black is about 0.3 volts, white is about 1 volt. Okay, so we should see things between 0 and 1 volt, basically. And how do we do that? Well, there's a voltage divider here, and then there's this followed by this emitter follower, which actually drives the output. But we've got 5 volts coming in here, and then a voltage divider. So you see this; these are the sync pulses coming in here. If this is at 0, which means the sync pulse is at 1, either that's vertical and horizontal sync. So if either of those is at 1, that forces this to 0, which effectively puts the base at 0 volts. Okay, and I know it's not exactly 0, but for first order of approximation, that's 0 volts. So that will give us 0 volts on the output. And then this one would be when this is at 0. This is the pixel data coming through. When this is at 0, that's at 1 and so on. So when that's at 0, then this point is at 0 volts, and you get the voltage here on the base of the transistor based on these two resistance values. And when they're all off, that is, there's no sync pulse, and the pixel value is a 0 or black level, then this extra resistor is added into the mix, and so we get another a different value here. So this is switching this resistor in or out is how we switch between black and white. Okay, or whatever that was, 0.3 volts and 1 volt. So the 1 volt is pretty much the default. And then if this output is at a 0, then we'll get 0.3 volts, somewhere in that range. It doesn't have to be exact. That's what the brightness and contrast controls are for on the monitor. And if you get a sync pulse, then it pulls it to 0. Okay, so this is the monitor that I plan to use with this. Can you see that? Yeah, you can see that. The problem with it is, it's not a problem. It's a problem for me. It has BNC inputs, you see there. And I don't have the appropriate adapter or cable right now. So we're going to have to look at it on the oscilloscope. Yes, the world's worst oscilloscope. Here it is. I have 2 channels here. What I'm looking at on channel 1 is the vertical sync output from the processor chip. When I say processor here, I mean the graphics processor, not the central processor. And that's a positive going pulse. And so, and then on channel 2, I have the composite video output. And so you'll see here, channel 1 is a TTL level. It's going to show between minus 0.5 and plus 5.5 volts. The composite video is going to show between minus 0.25 and plus 1.25 volts. Okay. And as far as triggering goes, trigger on the rising edge of channel 1 when it hits half a volt. So what we can do then is turn this on. Oh, except my flaky power strip is acting up again. Okay. We turn the power on. And start that running. And then we start this running. I said we start this running. I said, where's my waveform? Well, there it is. Okay. And at this setting, you can see, okay, so there's my vertical sync pulse, vertical sync and horizontal sync pulses. And in here, each one of these represents a line. So we would be seeing, should be seeing, you know, if it was outputting anything other than just solid black. Whoops, and I've lost my power again. Okay, that's great. Flaky. Okay, well, it doesn't, I don't need it. Well, I will need it. Let's see, if it was anything other than solid black, then we would see this. Well, actually, it's solid white right now. And we'll have to take a look at that because that's about 1 volt, right? So that's 1.25 volts. Black should be down around here. And actually, we should be seeing solid black right now, I would think. The screen is, how you say, muted. That's not the word I want. Blanked, I don't know. But anyway, we'll look at that in a minute. What I want to do first of all is, well, let me zoom in a little. I'm going to look at these pulses. Each line should be about 63 microseconds. So I want to make sure that the pulses look correct. So we'll set that cursor there. That's called X. Oops. We'll move O to the rising edge of the next pulse. Or is it the following? No, it's in the rising edge of the next pulse. Right around there. And you can see it is 63 microseconds, X to O. So that looks good. I think I've got the timing right on that. The vertical sync pulses should be at a 60th of a second. And I'll have to change the, definitely change the settings here, because that's like 16.7 milliseconds or something. So we've got to crank this way up. Let me see if I can get this running again. Long enough to, okay, yeah, oops. Well, that's not going to work very well. Okay, there. We'll stop that. I've got 2 vertical pulses right there. And I can, well, okay. I'll move O over to here. And let's see, go down there, cursor moves, X, move that back over to there. I hate this oscilloscope. Have I mentioned I hate this oscilloscope? I wish I had a modern 21st century digital storage scope, but I've been making do with what I have. Okay, so that's approximately at the leading edge of that one. That's approximately at the leading edge of that one. 16.68 milliseconds. That's pretty close to 60 hertz. So, and never mind this. That's sampling issues with this scope. And so you're not actually seeing, you know, black and white levels there. Okay, speaking of black and white levels, we should be at black level, we're at white level. Why is that? Let's go back to the schematic. See that? Okay. let's see. If I pull, let's see. This is 0 here pulls down to black level. So black would be a 0 here, which that's an inverter. So that means it's a 1 here. That's an inverter, which means it's a 0 here. And that is fine, except that you can see here's the pixel data coming out of the shift register. And it goes, and there's an inverter there. There's a NAND gate. And that probably should have been an AND gate. So my data is inverted, my pixel data. Also coming from here is the blank signal. So blank comes in, that's active high. I take the inverse of that. So if blank is a 1, this is a 0, that would force the output of this to a 1, which should be black, but 0 at this point is black. So I can work around this by connecting this to the inverted output rather than the non-inverted output. So another little blue wire on the board. Now I know some of you out there are probably thinking, oh, come on. Don't expect us to believe that he actually made that mistake. You did that on purpose so that you would have a video to make. Well, I have no comment on that. But I'll have to move that from pin 9 to pin 8. It was pin 5 of this one, from pin 9 to pin 8, and that should invert the video, and so we'll do that and come back to it and see if we get a different level. Okay, and here's what that mod looks like. I didn't even use a blue wire. I just used a little bit of, that's actually, I think, an old resistor lead or something. It was, this line was going to pin 8 there, 9 rather, it now goes to pin 8. So I'll get that back together and we'll try it. Okay, so it's all back together. And let's take a look. I need to set this back to, what was it, about 2 microseconds? We'll see. Oh, wait. Helps to hook the power back up. What? There we go, and it goes there. Okay, and as I was saying, powering up. Okay. Do that, do that. I said, do that. I don't know if that's working. Okay. And we're running, and oh. Now what am I seeing? This is weird. Yeah. So you can see here's, we're at about 0.3 volts here, which is black level. And then the 0 volts is the sync level. And we have no white right now because it's just, as I said before, the display is blanked. So that seems to have resolved that problem. So the next thing to try would be to get those cables or adapters and actually hook it up to the monitor and actually try to send some video signals other than just a black level out to it.